Exercise 306 is going to show you a method which you can solve equations through looking at the intersection of the lines. So when we graph the equations, we will graph two separate straight lines and we will find their point of intersection. Now, just a little background to that. What this point of intersection does is it gives us the solution for the x and the y values. So if you have a look at this equation that I've drawn here, y equals 3x plus 1, we cannot solve that. You've heard me say many times, to be able to solve an equation, you can only have one unknown. So if I've got two unknowns, which I do here, x is an unknown, y is an unknown, I will need a second different equation. So along with knowing that, I might also know that y is equal to minus 3x. Now, so there's my second equation. So this we call equation 1, this we call equation 2. With two equations, we're able to solve. That means we're able to find the x value that makes that equation true and that equation true, and the corresponding y value that makes that equation true and that equation true. There is only one xy set that make both those equations true at the one time. So a nice easy way to find that is to draw the intersection of these two lines. What do we know? We know that in this case, positive 3 gradient cutting at plus 1, so it'll be a line doing something like that. And this one is negative 3x going through cutting at 0, cutting at 0, because I've got a plus 0 on here, and having a negative gradient, about the same slope. Whoops, that's meant to go through there. This, if I read off that x value and that y value there, I have the solution. You may have talked about this previously and called it the graphical solution, because we're graphing the lines. So it says when you have two equations involving two unknowns, two equations, two unknowns, x and y, you can solve them simultaneously by graphing each line to find their point of intersection, which you can see I've just demonstrated here. Point of intersection. From that point of intersection, I read off the x value and the y value. That gives me the solution to those two equations. This point of intersection and regions either side are significant for real-life situations. They're sometimes called the break-even point. Now, if any of you do business studies, you know that in a business, if you're breaking even, you're running your business and you're only just breaking even, means while you're not losing money, you're not making any money. So you want to be in a situation where you are making a profit, and once you draw these graphs, you're able to see that where you need to be operating in order to make a profit. So basically we will be drawing the equations. Remember, this was the graph of y equals 3x plus 1. This was the graph of y equals minus 3x. I didn't do it very accurately. To do it much more accurately, you would draw up a table of values. You would be using a ruler and a scale, and you would plot those points accurately. Same thing for this one. And you get a very accurate point of intersection. Let's have a look at this example. It's a good example because on first glance at these equations, it looks like we've got 1, 2, 3 different variables. I'll show you why that's actually not the case. Ali is organising an outdoor morning tea to raise money for a charity. The cost of hiring a marquee is $116, catering is $6 per 20. To cover these costs, Ali is charging each person $12. The cost and revenue. So cost is dollars, say, going out, and revenue are dollars coming in. So really we could replace that with dollars, and we could replace that with dollars, and now we only have two variables, a dollars, an N, a dollars, an N. The N represents the number of people. This dollar represents the cost. This dollar represents revenue, which is money coming in. And it says that here where R and C are in dollars, and N is the number of people. It would be like our graph now has dollars and N. In that way then we can draw these two graphs, 6.2N plus 16 on here, and we can draw 12N on here. And we will find the point where they intersect. So you can see I am going to fill out a table of values for N from 0 to 50. Now we really only need ever 3 values for a straight line. So I've just chosen 20, it's sort of in the middle. I'm going to do calculations for the cost using this formula here. So the 6.2 times N plus 16. So the first calculation I need to do, or I've done, that you can see, is I've taken N is 0. I've taken the formula C equals 6.2 times N, which is 0 in this case, plus 116, and you get 116. And that's where that number there comes from. Next, I've considered when N is 20. And the cost would be 6.2 times 20 plus 116, and I've calculated that to be 240, and that's where that 240 comes from. When N is 50, we do the calculation, we get 426. So what I know from my table is I need to graph the points for cost 0, 116, 20, 240, and 50, and 426. Now you can see that I have sort of set up my graph. I'm not prepared at this stage to commit a scale on the vertical axis, because while I know that the cost goes to 426, and somewhere I've got to make sure I can get at least 426, at this stage I don't know what the revenue amounts of dollars will be, the biggest value, so I wouldn't put my scale on yet, and I won't graph those points. So I'm going to pause the video now, and I'm going to do the calculations for a green line that I will draw, which will represent the revenue. To get the values, the points that I need to plot, I will be using this formula. So you can see here I've done my calculations in green, considering when N is 0 and I want to fill in this space here. To do that, I use the equation 12 times N, and if you've forgotten it, it came from there. R is equal to 12 times N. So that gives me $0. Now, I'm wanting to know the revenue when N is 20 and fill in this spot. Where did that 240 come from? It came from this calculation here. When N is 20, R is 12 times 20, and 12 times 20 is 240. You can probably see that we've got a similar situation the blue line goes through 20 to 40, the green line will also go through the point 20 to 40. But to complete the green line, I've got to consider when n is 50. When n is 50, r is 12 times 50, which is 600. So now I need to plot these three green points and join them up. So I've got the revenue line, and they will be at 0, 0, 20 to 40, and 50, 600. So you can see that it was a good idea for me not to commit 420 to the top of my scale, because in fact I need my vertical axis to go up to 600. So you can see I've graphed the two straight lines, and remember the green one representing the cost and the blue one, no, other way around. Green one representing the revenue, money coming in, and blue one representing the cost. And at the point where you invite 20 people, your cost equals your revenue. So you're not going to lose money, you're not going to make money. If you have less than 20 people coming to the afternoon tea, 10 people for example, you can see the cost at 10 is higher than the revenue. So the costs are greater than the money coming in. It means you're going to have a loss. You're going to have to pay more than what you're getting. Anything after 20 people, the money you're getting in is bigger than your cost. And that gap widens. So we've got a gap like that, then a gap like that, and then this is representing our actual profit. So the point of intersection is 20 and 240. And the other part of the question asks you to use the graph. And anytime you're asked to use the graph, then you must put markings on the graph, which you'll see me do in a moment. Just checking for the cost. So we're going to the blue line for 12 and then 30. So for 12 people, we're coming up here at 12 until we get to the cost. And it looks like the cost is approximately $200. So 20 people cost is $200. Oh, sorry, that was 12 people. My mistake. 12 people, the cost is 200, and 30 people. For 30 people, we're going to come up this line till we get to the cost, and the cost is approximately there, and we come across and we can see for 30 people the cost now looks like about $300. So hopefully you've got some key points that you can write down from that video and get started with 306.